Hello, Ubiquitous. I'm glad to present my work ViFin harmless passive vibration to continuous microfinger writing with a commodity smartwatch. So this is a joint work with my university, University of Virginia, and University of Washington, and the company ViFin AI Limited. So finger writing is a very popular way we use to achieve device input nowadays. And 2 years ago in Census, the researchers, they put some sensors on the fingertip to achieve the finger gesture recognition. And last year in Ubiquitous, the two paper, they put sensors on the fingers, or they put cameras to check the finger movement so that they can recognize the continuous finger movement. But these are customer device and they cannot be achieved with commodity smartwatch. It will be more difficult if we just use this commodity smartwatch to achieve this continuous finger writing. And yet there is a work like ViFin. They use this commodity smartwatch to recognize gestures, but these systems cannot recognize continuous microfinger writing. And our contribution in this work of ViFin is we can achieve the continuously microfinger writing just with a commodity smartwatch. So how it works? Our observation here is when we move our finger, the vibration will propagate through the hand to the smartwatch. And as we can see, when we write 1, 2, 3 CAR, here is the vibration captured by the smartwatch IMU. And we write continuous 1, 2, 3 here, we write CAR call here, we write cat here. And interesting, in this red box, we can see CA in the call, CA in the cat. The vibrations are very similar. So based on this observation, we believe that just with the IMU in the commodity smartwatch, we can recognize this micro continuous finger writing. And what's the challenges here? Firstly, how can we recognize continuous finger writing? And secondly, people write differently, people have different hand shape. So can this system work across different users? And third, can this system be robust, which means it can recognize the finger writing in different writing speeds, different arm positions, and different and write while they're walking. So firstly, so if we write a letter A and a letter B, so we can just use a slide window to cover this vibration, like a 4-slide window. But the problem is, sorry, how can we label them? It can label AABB, ABBB, or AAB. And our idea is we can just consider all the possibility. We sum up all the probability, but it's too much computing. So instead of the method of exhaustion, we use the dynamic programming, the forward-backward algorithm, so it can calculate more efficiently. And then we use a GRU network to train the system. And it can, for example, it can get the result of AABB, and with a simple training, we can cancel these repeat letters and be AB. But what if we write hello? So there is a problem. We don't want the HELO. And inspired by recurrent neural aligner, we know we need to add another class labeled it none. So in this way, we can recognize hello. And this is the neural network architecture. The second challenge is people can write differently, like in this way or in this way, and people have different hand shape. So here we use transfer learning to fine-tune the new users. And also we have a calibration and update scheme to make sure the system works robust, and we have spell check to know like which letters you are not cannot be recognized well, so we can keep update and retrain the system. And we also achieve some training-free gestures based on the gyroscope angle, so we can know can have some gestures to wake up the system, delete the test, or enter the test. And here is the figures of the gyroscope angle, so we can know, we can recognize, twist the angle and move left, right, up, and down. So we achieve this system as a standalone application program on commodity smartwatch, and we connect this smartwatch to the McGuire glasses. So on the smart glass screen, we can see the text output, and we just use the accelerator and gyroscope, the built-in IMU sensor. And we collect 15 participants' data with numbers and letters. And we have validation set here, and we test on a standard public key transcription. And we ask the users to write 2 hours on this transcription. And the accuracy, the average accuracy is 90%. For more accuracy evaluation details and the real-time evaluation, we test on in the real world for the real users as well as the user study. And please go to our paper details. In summary, the contribution of this work is we achieve a microfinger writing, and it works continuously, and we have comprehensive evaluation in this system. Lastly, let's see the demo. Thank you.